Okay, so let's do a worksheet on these chain rule problems, including ones that involve logarithms and exponentials. Okay, let's get into it. All right, so again, when I start doing this here, and I start looking for the derivative f prime of x, I want to look at the structure of the function. And I basically see it's something cubed. So if it's something cubed, then I would do 3 times that something squared, and then multiply by the derivative of that something. So soon I'll start, skipping that, writing that as a separate step, but I'll do that here in this one. So it's 3 times 2x minus 7 squared times the derivative of 2x minus 7 is 2. So overall I get 6 2x minus 7 squared. Okay. G of x is ln of x cubed. Ln of x, all cubed. Notice a difference there. This is not ln of x cubed, or in other words, it's not the x that's getting cubed, it's all of ln of x. So it's a different situation. So what we have here is, again, just like before, we have something cubed. So it's very similar to part A there. So g prime of x, then, it's something cubed, so 3 times that something squared times the derivative of that inside something, ln of x. So 3 ln of x squared times 1 over x. Or in other words, 3 ln of x squared all over x. Okay. How about e to the minus 2x? Well, again, I look at that as e to the something. So it gives itself back, e to the minus 2x, and then I have to take the derivative of the minus 2x, which is the something, and I would get a minus 2. So I get minus 2 e to the minus 2x. Done. Now in this one here, y equals the square root of 2 minus t. All right, one, I have the variable t in here. And the second thing is, I don't like how it's written. I'm going to write it as 2 minus t to the 1/2. And then I really see that this is just a traditional power rule with the chain rule. So y prime then is 1/2 2 minus t to the minus 1/2 times, now the derivative of 2 minus t is 0 minus 1, so minus 1. So essentially you're getting it from the minus and the 1t. Okay, so I get minus 1/2 2 minus t to the minus 1/2, and that would be okay. Or if somebody wants to go back to radical notation, I could write this as minus 1 over the square root of 2 minus t. Whoops, 2 times 2 minus t. I can't forget that too. Okay. All right. So this one may look a little nastier than the previous ones, but it's not really that bad, because essentially all I have is I have this something to the 2/3 power. So it's a chain rule, power rule situation. Really power rule then chain rule. Okay, so I have something to the 2/3, so 2/3 times that something, 3 minus x squared to the 2/3 minus 1. So that's 2/3 minus 3/3, that's minus 1/3. Times, and then I go inside and take the derivative of 3 minus x squared, which is a minus 2x. And so I'd get minus 4/3 x, because of the x there, times 3 minus x squared to the minus 1/3. Okay. 4 times 5x minus 2 cubed. This is like what we've done before. It's just 4 times something cubed. So it's 12 5x minus 2 squared times, go inside and take the derivative of 5x minus 2, and I get 5. That's a 5. And so I get 12 times 5, that's 60. 5x minus 2 squared. Okay, so in this one, I actually do have a choice. I could do this as this thing inside squared and end up doing a quotient rule inside, or I could be a little slick and realize that I could also write this as t minus 3 to the minus 2, because it's really t minus 3 to the minus 1 inside raised to the 2, so I get t minus 3 to the minus 2, which will make my derivatives easier. So what you see is that algebraic manipulation before doing derivatives often makes the derivative taking easier. All right, so y prime now is, so it's something to the minus 2. So minus 2 t minus 3 to the minus 3, minus 2 minus 1, times the derivative of t minus 3, which is 1. So I would get minus 2 times t minus 3 to the minus 3, or if you want to write that as minus 2 over t minus 3 cubed. Okay. So now f of x equals 3 tan pi x squared. Not a big deal here. Looks intimidating, but it's not really. I have f prime of x, so I just have 3 times tan of something. So the 3 is a multiplicative constant, it stays. Then I have tan of something. Well, derivative of tan is secant squared. So I get secant squared of that pi x squared. Then I have to go and take the derivative of pi x squared. But that would actually be 2 pi x. So I get 6 pi x secant squared of pi x squared. All right, let's take a look at some maybe nastier looking ones. All right, f of x is e to the radical x. Maybe I want to take a look at this as instead f of x equals e to the x to the 1/2. Okay, I don't like how that looks. Hold on. E to the x to the 1/2. Okay. So when I go and do the derivative, it's still e to the something. There's your something. So it returns e to x to the 1/2. Then I have to do the times the derivative of x to the 1/2, which is 1/2 x to the minus 1/2. So I could write this as 1/2 x to the minus 1/2 e to the x to the 1/2. But probably more likely you would see this as, okay, keep the 2 in the denominator. X to the minus 1/2 is a radical 2 in the denominator, because that's x to the 1/2 in the denominator. And then I'll go back and write e to the x to the 1/2 as e to the radical x. So it looks a little nicer when in this case, when I put the radicals in. Okay, when I take a look at this next one, y equals ln of x times radical x squared plus 1. Whenever I have the logarithms, ln, or any other logarithm, I want to think about doing simplification first. In other words, I have ln of a product, so I can write that as ln of x plus ln of radical. Well, I'm not going to write the radical because I'm going to go to 1/2 notation. So ln of x squared plus 1 to the 1/2 power. Because then I see that I have ln of something to a power, which means I could write that second part as 1/2 times ln of x squared plus 1. And now I have a much nicer form of this for derivative taking. Okay, so y prime then, I take the derivative of ln of x, I get 1 over x. Then I have plus constant multiple 1/2. Derivative of ln of x squared plus 1 is the derivative of ln of something. So 1 over x squared plus 1 times the derivative of this something, which is 2x. So these 2's cancel, And I would get 1 over x plus, don't forget this x here, x over x squared plus 1. There you go. All right, how about g of x is 4 to the x squared? Well, again, let me look at the structure. It's basically 4 to something. So 4 to something is a type of exponential. So it gives me back 4 to that something, 4 to the x squared. But it wasn't base e, so I have to multiply by ln 4. And the chain rule says I have to then multiply by the derivative of x squared, so by 2x. So I end up with 2x ln 4 times 4 to the x squared. And there's not a lot I can do with that. Could mess around with the ln's and stuff like that, but that seems like a decent answer. Okay. How about y equals log base 10 of 4x? Okay. So again, it's basically log base 10 of something. So y prime is, so log something, so then it's 1 over that something, but then because it's not base e, I need a correction factor of ln 10 down there, and because of the chain rule, I need to multiply by the derivative of 4x, which is 4, and these 4's will cancel, and I get 1 over x ln 10. Okay, now let's look at a really messy one here. And there's a lot going on in here because of multiple layers and notation. Okay, so the first thing here is sine squared of 3x squared. This is not a helpful notation here because this sine squared is a shorthand notation. I might actually be better off seeing this as sine of 3x squared all squared. Okay, because now I see what is the outermost thing. The outermost is the squaring. So I have all of this being squared. So that's the something inside. So when I take the derivative, I have something squared. That's the first level, something squared. So I have 2 sine 3x squared, and then would be to the 1 power, but I'm not going to write that, times, and then I go inside and I need to take the derivative of what was inside. But that's a new chain rule. That's sine of something. That would give me cosine of that something, the 3x squared. And then I'd have to go in and take the derivative of the something from that, the 3x squared, and get 6x. So I end up with, all said, I end up with 2 times 6x is 12x sine 3x squared times cosine of 3x squared. That's a good answer. You might see some people combine the sine and the cosine using sine of 2 theta idea, but we'll leave it at that just to focus on chain rule here. So there are actually 3 levels in here. Okay, you had something squared, and then when you went inside, you had sine of something, and then ending with the 3x squared inside. Okay? And that's how the chain rule can have multiple levels to it.